Okay, so for today we will be talking about section 3.4 of our course, solving quadratic equations. So, a quadratic equation in one variable is an equation equivalent in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a not equal to 0. So notice this assumption, a not equal to 0, because if a equals 0, then at the very most, we will only have a linear expression. So we don't want the coefficient of x squared be equal to 0 so that it appears there, or that term x squared appears in the equation. So our goal is to solve this type of equations, and I will be presenting some methods on how to solve these quadratic equations. Okay, so solutions of quadratic equations. First, suppose we have some number p greater than or equal to 0, and we have the equation x squared equals p. Okay, x squared equals p. Then the solution to this equation are the following. X equals square root of p, or x equals negative square root of p. Okay, so the solution set of the equation x squared minus p equals 0 is the following. We have square root of p and negative square root of p. Okay, so if you remember one of the examples that we discussed last time, but anyway, I'll just put another example in here. So for example, I think we had x squared equals 25. But in any case, if I don't write the previous example here, but we'll just have this as our example. X squared equals 25. So this means that the solutions are x equals plus or minus square root of 25. And we know that square root of 25, that's just equal to 5. So this is equal to plus and minus 5. Okay? This notation here, plus minus, and then here plus minus, it's a shorthand notation for x equals 5 or x equals negative 5. Okay? So that's just a shorthand notation. X equals 5 or x equals negative 5. Okay? So another example, maybe you have x squared minus 2 equals 0. Then this means this x squared minus 2 equals 0 can be written as x squared equals 2. And this means that the solutions of this equation, x squared equals 2, is, or the solutions are, x equals plus or minus square root of 2. Okay? So this is the easiest quadratic equations to solve. So notice, your p must be greater than or equal to 0, meaning the right-hand side of this equation. So x squared equals some number. That number on the right-hand side must be positive or equal to 0. Okay? Positive or equal to 0. Okay? So just like this, we have x squared equals positive 25. Here, we have x squared equals 2. Okay? So that's the first. The next solution is the following. Our next way of solving quadratic equations is the following. The use of quadratic formula. Okay? So in here, let us consider the equation ax squared plus bx plus c equals 0, okay? Ax squared plus bx plus c equals 0, where a is not equal to 0. Now, if you calculate this, b squared minus 4ac less than 0, so you have here b, a, b, and c. Compute for b squared minus 4ac. If the number you obtained is less than 0, then this equation here has no real solution. Okay? So this equation here has no real solution. If you calculated b squared minus 4ac and got some negative number. Okay? If b squared minus 4ac is greater than or equal to 0, so you calculated this and then you found the number to be greater than or equal to 0, then this equation here has real solutions. And the solutions is or are given by this formula. Okay? So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay? Quadratic formula. So x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So notice you have that b squared minus 4ac inside the square root symbol. Okay? Inside the square root symbol. So that is why if your b squared minus 4ac is negative, you will have no real solution. Because if you use this quadratic formula, you will have something square root of negative number. And I mentioned that before, that we don't calculate square root of negative numbers. Okay? We don't calculate the square root of negative numbers. Okay? So, we call this number b squared minus 4ac, okay? B squared minus 4ac, the discriminant of the equation. So, we have this b squared minus 4ac, the discriminant of the equation. Okay? Now, if you're going to ask, where did we get this a, b, and c? They are just the coefficients. Okay, so a, it's the coefficient of your x squared. Your b, it's the coefficient of your x term. And your c, it's just the constant term. So you'll just collect those coefficients, and then you just input it in this formula, in the quadratic formula. Okay? Okay? So, for the quadratic equation, ax squared plus bx plus c equals 0, where a is not equal to 0, okay? Where a is not equal to 0, if b squared minus 4ac less than 0, then the equation has no real solution. Okay? Just like what the theorem in the previous slide said. If b squared minus 4ac is less than 0, then the equation has no real solution. Okay? If b squared minus 4ac equals 0, okay? If b squared minus 4ac equals 0, then the equation has one solution and it is repeated. Okay? So meaning, technically, this equation has two solutions, but the solutions are the same. Okay, that's why we call it a double root. Okay, double root. Okay, and then If b squared minus 4ac is greater than 0, okay, if b squared minus 4ac is greater than 0, then the equation has two unequal real solutions. So you will get two real solutions which are distinct. Okay? So again, if b squared minus 4ac is less than 0, the equation has no real solution. If that discriminant b squared minus 4ac equals 0, you'll get one solution. But that solution is repeated. Okay? And if your b squared minus 4ac is greater than 0, you will get two unequal solutions. Real solution. Excuse me. Two unequal real solutions. Okay? Questions so far? Now, we want to do some solving of quadratic equations. Okay? But here's what you're gonna do. If you are familiar or if you remember factoring, remember we discussed factoring previous weeks, okay? You can always use that factoring method, okay? What you do, you put everything, on the left-hand side and then equate it to 0, okay? And then you are going to factor, okay? You are going to factor this equation, okay? You are going to factor this equation, and then once you are able to factor it, you will be able to solve the quadratic equation. Okay? So before I proceed to the next example or to the examples, okay? Suppose you have your ax squared plus bx plus c. This is equal to 0. Okay? Now, instead of writing small letters here, A, B, and C, let me write capital letters. So you will remember the method, what the method we were using before. So you have your ax squared plus bx plus c equals 0. So it is possible to solve this quadratic equation without using your quadratic formula. Of course, the quadratic formula, let me go back to that part. This quadratic formula, it's the best. It's the exact, okay? This is, this formula will give you the exact solution of this equation immediately, okay? And this will have no problem unless you don't memorize this. Okay? So basically, you will need to memorize this in order to find the solutions of this equation. Okay? But again, are there other ways to solve the equation? So
I have a
by
question.
factory. Yes,
Sorry.
question? Yeah.
So will this equation be something that would be on the paper we have with us on the exam, or it's something you think
It's something that you actually need to memorize. That's a good question. Yes, you need to memorize that one. Because if I put that, then there's no point of asking. Okay? There's no point of asking you to find the solutions of a quadratic equation if I put the quadratic formula, because all you need to do there is to substitute the coefficients. Okay?
Kelvin,
Yes.
I have a classmate who's asking if you could check your mail because she cannot log in the class.
Um,
I'm sorry.
cannot log in into the class. Why? We are using the same. Maybe it's logging in a different.
Okay, I will copy and paste for her.
Yeah,
Okay, thank you.
you're welcome. Okay, did I answer the question in regarding to the quadratic formula? You see, if I put the quadratic formula in the um, questionnaire, then you'll just have to substitute it, and then there's no. Uh, it's not really a question, or it's not really knowing if you know how to solve a quadratic equation. That one will just inform me that you know how to substitute the values in the quadratic equation. But the point of this is I want to know whether you know how to solve quadratic equations. Okay? No, I won't provide the formula. That's what I am saying. So if you're asking if I'm going to provide the formula, the quadratic formula, no, I won't. So you will have to memorize that. Okay? But then again, if you don't memorize the quadratic formula, then you can always use another way of solving quadratic equation. So as I have mentioned, you have this quadratic equation, ax squared plus bx plus c. You can always factor this. You can always factor this into something x plus x plus r, say x plus r1, okay? And then times x plus r2 equals 0, okay? X plus r1 times x plus r2 equals 0. And once you are able to factor this, okay? Once you are able to factor this equation into this form, then the solution, the solutions are, the solutions are, the solutions are, you have x equals negative r, r1, and negative r2. Okay? Let me change this. Instead of plus in here, let me put this minus, and then here it becomes plus. Okay? So let me reverse those two guys. So in here, instead of plus r1, I'll put minus r1. And in here, you have minus r2. So that the solutions will be x equals r1, x equals r2. Okay? So the question is, how are you going to factor this equation here into this form? How are you going to factor this equation here uh, into this form? Okay? So remember, if I'm going to multiply this, if I'm going to multiply this, okay, we will get x squared minus r1 plus r2 x plus r1 times r2 equals 0. Okay? Just multiply. Use FOIL method if you want. Okay? So x minus r1 times x minus r2 equals 0. What you will get is x squared minus r1 plus r2 x plus r1 plus r1 times r2. That will be the left hand side. And the right hand side, this is equal to 0. Okay? And then this R1 and R2, these numbers will then satisfy the following. So, okay, so we have, so we have minus R1. So let me distribute that minus R1 minus R2. This must be equal to B over A. Okay? Or maybe we can write this as R1 plus R2. This is equal to negative B over A. And then the product R1 times R2. This is equal to C over A. Okay? 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 And therefore, remember what we did when we are factoring this quadratic equation. Okay, there is a method that we discussed in on how to factor this equation here. We find the product AC, we find small numbers A, B, C satisfying these conditions. It's exactly the same method. It's exactly the same method. But in here, R1 and R2, they can be any real number. They can be rationals or integers. Actually, not any real number, but they will be rationals or integers. Okay? And could be irrational, I guess. Could be irrational. But in any case, you will have to find your suitable R1 and R2 satisfying these conditions. Okay? Satisfying these conditions. So we will look into that later. Okay? But again, the idea is you will need to factor this equation here. You will need to factor this equation or this expression on the left-hand side into something like this. Okay? Into something like this. And once you have factored the expression on the left-hand side into something like this, then you will get the solutions. Okay? These solutions are obtained as in the following manner. So this guy here means that you have your x minus r1 equals 0, or x minus r2 equals 0. And that's why you will have x equals r1 or x equals r2. Okay? So that's why we have this. And remember, this, so from here going to this, okay, from here going to this, the property of real number that we use is the following. If you have the product AB equals 0, then A equals 0 or B equals 0. Okay? A equals 0 or B equals 0. Okay?
I have a question.
Yes, question.
Are here like before in formula like plus B will be B capital, yeah?
Yes, what is the question again?
Uh, Variable R,
These guys here.
R1, yeah.
These are some numbers that you need to solve satisfying this condition.
So A here is always common denominator, yeah?
Yes, you divide everything by A. Because
Supposed to be, yeah?
if you expanded this, look at this. The coefficient of x squared becomes 1. So to make the coefficient of x squared here 1, you divide everything by A. That's why you have here B over A and then here C over A. Okay,
Okay, thank you.
you're welcome. Okay, other questions? Okay, and again, if you still remember the the method that we discussed in the previous week, that's exactly similar to this guy here. Okay, that's similar to this guy here. So you can use that one actually. Okay, you can use that one. Okay, let us consider some examples here. So there is a question. This is another formula that we can use to solve for quadratic equations. These are not formulas because you will have to solve for this. This is another method, if that's what you meant. This is another method in solving quadratic equations. So we have two methods that I just presented two methods. The first is your quadratic formula, which you need to memorize. And the second method is this guy here, factoring. Okay, factoring. Okay, and if you remember completing the square, the one that I mentioned, okay, the one that I discussed also when we were dealing with factoring, completing the square is another method. Okay, so basically we are done with solving quadratic equations. The methods in solving the quadratic equations, they have been discussed in the previous lectures. Okay, all we need to do is we apply those methods into solving quadratic equations. Okay, and more commonly, factoring is really helpful in solving quadratic equations. Okay. Okay, so let us consider the following. So we want to solve x squared minus 6x equals 7. X squared minus 6x equals 7. Okay, so for these first few examples, I will include the solution in this lecture video. And then for the latter examples that I have prepared, I will not include the solutions. Okay, in the lecture videos. So we want to use, so in here, we have x squared minus 6x equals 7. What we're going to do is to use completing the square. Okay, we want to use completing the square in solving this equation. Okay, so how are we going to do that? You start with this side, and then you just leave this alone. The 7 on the right hand side, you just leave this alone. What we're going to do is to write this left hand side here as a perfect square trinomial by adding and subtracting some number. Actually, we will add something into this left hand side, and then we will add the same thing on the right hand side. Okay, so what are we going to add? What are we going to add? Remember, if you have x minus a squared, this is equal to x squared minus 2ax plus a squared. Or if you have x plus a quantity squared, you have x squared plus 2ax plus a squared. Okay? So we want to turn this left-hand side into something like this, the left-hand side in here. So we will have to find the a squared for this left-hand side. And we can find that using this formula. In particular, notice you have minus 6 in this, minus 6x. And then in this formula, you have minus 2ax. Okay? So if we compare these formulas here, okay, what we will get is the following. You will have 6 equals 2a. So minus, that's minus. You have 6, you have that 2a, and then of course your x is this x. Okay? Okay? And therefore, your a here, so 6 over 2, this is your a, or your a equals 3. Okay? And therefore, you have a squared equals 9. Okay? You have a squared equals 9. So what we're going to do is to add 9 on these sides and also add 9 on this side. Okay? Question so far. So here's what we're gonna do. We add both sides. 9 on the left-hand side, 9 on the right-hand side. That's what we have obtained in our calculation here. So we need to add 9 on the left-hand side. We need to add 9 on the right-hand side. And therefore, this left-hand side now can be written as x minus 3 squared. Okay? Of course, on the right-hand side, you have 7 plus 9. This is equal to 16. Okay? Okay? Now, remember this? The first method that I discussed earlier, you have something x squared equals p. This means that your x equals plus or minus square root of p. It's similar to this. Something squared equals 16. Therefore, that something that is being squared will be equal to plus or minus square root of 16. Okay? But square root of 16, that's 4. So that we have x minus 3 squared, x minus 3 equals 4 and negative 4. So let me write that detail here. So you will have x minus 3. This is equal to plus or minus square root of 16. And that square root of 16, it's 4. So you have plus 4 or minus 4. But that's equal to x minus 3. Okay? Following? And then, we need to solve for x. What we're going to do is to put this on the right-hand side. We put this 3 on the other side, so we have the plus part because this was minus on the left-hand side. So we will obtain this. X minus 3 equals 4 or x minus 3 equals negative 4. That's what we meant in this line here. And therefore, we will have x equals 7 or x equals negative 1. So we put this on the other side, that becomes plus 3. So 4 plus 3, that's 7. While on this side, we put this 3 on the other side, it becomes plus 3 again. So you have minus 4 plus 3, that's equal to negative 1. Okay, so we have these two solutions for the equation x squared minus 6x equals 7. Okay, question. So here, the next step is to verify that they are indeed solutions. So when x equals negative 1, we replace x with negative 1. So you will have negative 1 squared minus 6 times negative 1. And that's equal to 1 here. Then negative 6 times negative 1, that becomes plus 6. So 1 plus 6, and that is equal to 7. Indeed, okay, indeed, x equals negative 1 is a solution. Similarly, if you put 7, when x equals 7, you replace the x with 7, you will get 7 squared minus 6 times 7. This is 49 minus 42, okay? And that's equal to 7, okay? Question, okay? Now, some students will do this. Some students will do this. Okay, some students will do this. Oh, I have x squared minus 6x on the left-hand side. I can factor out x so that I will have x times x minus 6 equals 7. And then, wow, we have, so wow, it's easy. We have x equals 7 or x minus 6 equals 7. So I have the x equals 7 in here, and in here I will have x equals 7 plus 6, and 7 plus 6, that's 13. Yay, I have the solution. Okay? And this is wrong. This is exactly wrong method. It just so happened your x equals 7 appeared there. It's a luck. Okay? It's a luck. But notice our solutions are negative 1 and 7. 7 and negative 1 here. The other number that we obtained here is 13. So again, this x equals 7 appeared because of luck. It's just a coincidence there for this. But this method is totally wrong. If you do this, you won't get anything. Okay? The only way you can do this method is if the right-hand side is equal to 0. Okay? Just like the method that I showed here in the discussion before this example. Okay? This guy here. If AB equals 0, then A equals 0 or B equals 0. That's it. But for this guy, if the right-hand side is not equal to 0, then you won't get anything. Okay? Question? Question?
No, everything's fine. Thank you.
Thank you for the response. Thank you. All right. Let us go to our next example. We want to solve 10s squared minus 19s minus 15 equals 0. Okay? 10s squared minus 19s minus 15 equals 0. So in here, what we're going to do is to use factoring. So this guy here, we will try to factor. Okay, we will try to factor. And then let's see what we can do. So let me again recall our method of factoring. So you have your A, instead of X, let us use S. A squared minus plus B S plus C equal to 0. Okay, plus Z equal to 0. So follow me while I factor this guy here, okay, using the method of factoring that I discussed last or several weeks ago. Okay, so in here, what we're going to do is to find, so remember that, find A, B such that the product AB, this is equal to capital A, capital C, and then the sum A plus B, this is equal to capital B. Okay? Okay? And the method that I discussed just before doing the first example, you can have, so find R1, R2 such that R1, R2, this is equal to C over A, and then R1 plus R2 equals negative B over A. So it's the same thing, very much similar. From this here, what you will get is something like X minus R1, X minus R2 equals 0. The coefficients of X and X in here are both 1. But for this method, you will have some other coefficients for X and X. But they are the same. These two guys here, they are similar approach. Okay? So this is what we're going to do. This is what we're going to do here. The red method. Okay? So we use the red method. Let me just erase this blue one here. So we want to find small a and small b such that the product AB that's equal to AC, and then the sum A plus B that's equal to capital B. Okay? What is AC? Our AC, this is equal to 10 times 15. This is equal to 150. Okay? So we want to find several pairs for this 150 so that they will satisfy this condition. The product is 150, and the sum of the pairs that we obtained is equal to negative 19 here. Oh, by the way, that should be minus here. So minus 15 in here, so negative 150. So we want to find pairs for negative 150, okay, such that the sum of those pairs equals minus 19. Okay, and notice this 150, it's a big number, so we have to carefully choose which numbers we add or subtract, or which numbers we multiply with. Okay? So you have 150 here, and then you have your A, you have your B, and then you have your A plus B. And A plus B must be equal to minus 19. Okay? So choose a very good pair. Okay? Choose a very good pair. Okay? If we use, you look at this, if we use 10 and minus 15, of course, the product will be negative 150. But if you added them, you will get what? 10 plus negative 15, that's negative 5. That's not what we want in here. So use another numbers or another pair of numbers. Okay? Use another pair of numbers. Maybe, let me guess. Um, let me guess. So for example, I have 50 and then minus 3. Okay? 50 and minus 3. If you added them, you have 50 plus negative 3. This is what? This is 47. This is not a good number. Okay? And then one of your classmates actually suggested the correct pair. So we use negative 25 and then 6. And negative 25 times 6, that's equal to 150. Okay? And you see, negative 25 plus 6, this is equal to minus 19. Okay? Of course, some of you might not get this correct pairing at first or at second or at third try. It's totally fine. Okay? Some of you will be, are actually faster finding pairs. And of course, that's good. But if you can find the correct pairs immediately, it's totally fine. Just keep finding, keep searching for the pairs. And eventually, you will get the correct pairing. Okay? So, we have negative 25 and positive 6. So, what are we going to do now? So, in here, from this equation here, we will have, so let me write again, 10s squared minus 19s minus 15. This is equal to 0. And we write this as 10s squared minus, so you have minus 25 there, minus 25s, and then plus 6s, and then minus 15. This is equal to 0. Okay? So I think this has to catch up. I have written something in here. Yeah, this guy here. So 10s squared minus 19s minus 15 equals 0. We use this negative 25 and 6. So 10s squared minus 25s plus 6s minus 15 equals 0. And then you factor this by grouping. You group this, you group this. Correct? So if you group them, you will have 5s quantity, 2s minus 5, plus in here you have 3 times 2s minus 5. Of course, that's equal to 0. And further factoring gives us 5s plus 3 times 2s minus 5. This is equal to 0. Okay? Question. So, factoring. So, if you are not yet comfortable in factoring, especially quadratic equations, keep on practicing. Okay? Especially those expressions with with where the s squared or x squared or the squared part has a coefficient other than 1. So try to practice something similar to this. The coefficient of s squared here, it's not equal to 1. So try to practice. Okay? So you have this factored form. 5s plus 3 times 2s minus 5 on the left hand side, and on the right hand side that's equal to 0. Okay, so here's what we got. 5s plus 3, 2s minus 5, that's equal to 0. And remember, again, for emphasis, remember, if a b equals 0, then a equals 0 or b equals 0. So this represents your a, this represents your b. So a must be equal to 0 or b must be equal to 0. Okay? So 5s plus 3 equals 0 or 2s minus 5 equals 0. So use the zero product property. And then finally, we solve for s. So you put 3 on the right hand side, that's minus 3. You divide everything by 5, you will have this. So negative 3 over 5. In here, you put 5 on the other side, that's plus 5. Divide everything by 2 so that your s equals 5 over 2. So these are the two solutions for this equation. Okay? And you can do the verification. So here's the verification part. You substitute your s with negative 3 over 5, calculate, you will get that 0 on the right hand side. You use s equals 5 halves, calculate, you will still get that 0. Okay? Question. All right. Next example here. 3z squared minus 8z minus 10 equals 0. So for this, we use quadratic formula. A equals 3. The coefficient of z squared, that's 3. B equals the coefficient of z, so minus 8. C, that's the constant part, that's minus 10. Okay? So for quadratic formula, this is almost straightforward. If we calculate the discriminant, that's your b squared minus 4ac. So this is your b negative 8. So negative 8 squared minus 4 times a. A is equal to 3. That's your a here. And your c, it's equal to negative 10. So that's your minus 10 here. So if you calculate this, you will get 184. And it's a positive number. So you expect two answers in here. Okay? So, z, this is the quadratic formula. Z equals negative b plus or minus square root of b squared minus 4ac all over 2a. Your b squared minus 4ac has been calculated already. It's 184 in here. So all we need to do is to substitute. Negative, so negative b is minus 8. So negative of negative 8 plus or minus square root of 184 all over 2 times a. It's 3 again here. So just plug in. Okay? So if you simplify, you will have this. So 184, you will have 4 times 46. And 4, it's a perfect square again. So you can bring it out to obtain the following. So 8 plus or minus 2, square root of 46, all over 6. And then 8, 2, and 6, they are all divisible by 2. So that we will be able to simplify this as 4 plus or minus square root of 46 all over 3. So the plus part and the minus part represent the two solutions of this equation. Okay. Question?
No.
I have
You?
question. Sorry.
Sure. Go ahead.
Um, you told us if it's more than 0, we have two solutions. This is
Yes,
two
two
solutions.
distinct solutions. Yes.
What do you mean? Another one? You say it
This
was
guy
supposed.
here, your b squared minus 4ac. If it's greater than 0, you will get two solutions. One is the plus part here. The second one is the minus part. This guy here is actually 4 plus square root of 46 over 3 and 4 minus square root of 46 over 3. So those are two different numbers.
But you told us we have another solution. It's root. What mean root?
Root is actually the name of the solution. For equation, the solutions are called roots. Okay, so it's just another term. It's another terminology.
So
Solutions of equations, they are also called roots of the equations. They mean the same thing.
same thing. Oh, okay, that's it.
Okay.
Thank you.
Yeah, you're welcome. Okay. Other questions? All right. Let us proceed to the next example here. So suppose you have x over x minus 2 plus 2 over x plus 1 equals 7x plus 1 all over x squared minus x minus 2. So again, this looks like rational expressions, and we involve those expressions into an equation. So these are actually rational equations. But as we shall see later, these expressions here can be transformed into an equivalent quadratic equation. Okay? Now, let us solve this. First, observe x squared minus x minus 2. So this guy here, you can factor this into x minus 2 x plus 1. So x minus 2 x plus 1. This is equal to x squared minus x minus 2. Correct? And then here you have x minus 2, here you have your x plus 1. So basically, the least common denominators, the least common denominator, it's just x minus 2, x plus 1. So remember your LCM method. So anyway, we just multiply the left-hand side and the right-hand side by x squared minus x minus 2, or this x minus 2 times x plus 1. So that's your LCD, x squared minus x minus 2. So if we multiply this expression on the left-hand side, we multiply this expression on the right-hand side. And again and again and again, this guy here, it's just x minus 2, x plus 1. So if we distribute this into this, x minus 2 will be cancelled for the first term. So you will only have x times x plus 1. And then for the second term, the x plus 1 will be cancelled. So you will only have 2 times x minus 2. Okay? And that's what we will have in here. X times x plus 1 plus 2 times x minus 2. And then on the right-hand side, you will cancel all of x squared minus x minus 2. So you will only get 7 plus x. Are we good? So we just distribute and simplify. Let us simplify this guy here. On the left, you will have x squared plus x. That's your x squared plus x in here. In here, you will have 2x minus 2 times 2. That's minus 4. So you will have 2x minus 4. Okay? Question. So we simplify again. We simplify this again. And this is what we're gonna get. So we put this 7x on the left-hand side, this one on the left-hand side again. Everything will be simplified to x squared minus 4x minus 5. That's the left-hand side. The right-hand side is equal to 0. Okay? And then in here, we factor, we use quadratic formula. It's up to us. Well, actually, it's up to you. But in an exam or a quiz, okay, you will be asked to use you will be asked to use a method. Okay? If I ask you to use quadratic formula, then use quadratic formula. If I ask you to use factoring, use factoring. If I don't ask you to use specific method, then use any method you're comfortable with. Okay? So let us continue with the solution. That can be factored into x minus 5 times x plus 1. So let me put again what was the previous one. You will have x squared minus 4x plus 1. No, minus 5 equals 0. That was the previous. Okay, let me verify that. Yes, x squared minus 4x minus 5. Okay. Now, look at this. We use now the zero property. We will have x minus 5 equals 0 or x plus 1 equals 0. But in here, look at this. Exactly this guy here. We cannot have x plus 1 equals 0. Because if you look at the original equation, you have a denominator x plus 1. Correct? And therefore, we cannot have the denominator be equal to 0. So notice this guy here. According to this, x plus 1 equal to 0. But using the original expression, we cannot have this. So observe that the original equation requires x plus 1 not equal to 0 and x minus 2 not equal to 0. This guy here and this guy here shouldn't be equal to 0. Which means what? We must only get x minus 5 equal to 0 or that x equals 5. So when x equals 5, you calculate this, you will get the equality. Okay? That's how important checking is. Some students, they will stop at this. They will stop at this. Then they will say, oh, x equals 5, x equals negative 1. And then they will box that. Poof, they will get deductions. Because again, this negative 1 here won't be a solution. Because you will have x plus 1 equals 0. And you cannot have x plus 1 equals 0. So these are some of those instances where your checking part is important. Okay? So this guy here will be wrong. This one is just fine, but this guy here will be wrong. Question. Question.
No.
Good. Okay, let us consider another problem here. This time, word problem. The area of a rectangular window is to be 399 square centimeters. If the length exceeds the width by 2 centimeters, what are the dimensions? Okay, the area of a rectangular window is to be 399 square centimeters. If the length exceeds the width by 2 centimeters, what are the dimensions? Let us present the variables. So we want to find the dimensions. So we have to give variables to dimensions. So we let L centimeters be the length of the rectangular window. Okay? The length exceeds the width by 2 centimeters. Okay? Therefore, width is L minus 2. Okay? Width is L minus 2. Because length is greater than the width. So you have this L for the length, L minus 2 for the width. Okay? If the area of the window is to be 399 centimeters squared, then the working equation is L times L minus 2 equals 399. Remember, area It's just length times width. Length is L, width is L minus 2. So if you simplify this, you will have L squared minus 2L minus 399. That's equal to 0. So we expanded this, we distributed L, and then we put 399 on the left-hand side. So you will have this. And then you can do factoring, you can do what? Quadratic formula, and etc. Actually, you can do completing the square. Okay? Just for fun, let me continue from here using completing the square. So suppose I am here, I distributed this, you will have L squared minus 2L, and this is equal to 399. What I'm going to do is to add 1. You have plus 1 here, and then I'll have plus 1 in here. I chose 1 because I know L squared minus 2L plus 1. This is a perfect square trinomial. What I will get here is actually L minus 1 quantity squared. And on the right-hand side, I will have 399 plus 1. That's 400. Correct? And therefore, I will have L minus 1. This is equal to plus or minus square root of 400. Square root of 400, that's 20. So I will have plus or minus 20. Following? Therefore, L equals plus minus 20. And then we put this on the other side, you will have plus 1. So L will be the plus. It's plus 20 plus 1. That's 21. And then the minus, we have minus 20 plus 1. That's minus 19. But notice we are talking about length. It's a distance. It's a positive. This is negative 19. So we take L equals 21. So take L equals 21. And the width, this is L minus 2. This is equal to 19. Okay? And then you just give the conclusion. The length is 21 and the width is 19. Okay? Question? That's one way to solve. That's one way to solve this equation. If only I started with this. But there is, what if you don't remember completing the square? You look at this and then do factoring. That's totally fine. Or you don't remember completing the square and you look at this, you were overwhelmed, so you didn't want to use factoring, you just use quadratic formula. That's totally fine. You will get all the same answers. Okay? So this is one method. Let us use another method. So by factoring, solving the quadratic equation by factoring. So what we had in the previous slide was L squared minus 2L minus 399 equals 0. If you tried to factor this is what you will get. L plus 19 times L minus 21 equals 0. And then you solve for L. L equals negative 19 or L equals 21. But the length must be positive, so we only take L equals 21. In this case, the length is 21 centimeters, width is 21 minus 2, which is 19 centimeters, and the area is the product 21 times 19, that's equal to 399. Okay? Question?
No, sir.
Thank you. Let me now go to the next. Yeah, you'll have question? No. Let's now proceed to the next here. An open box is to be constructed from a square piece of cardboard by removing a square of side 4 inches from each corner and turning up the edges. If the box is to hold 576 cubic inches, what should be the dimensions of the cardboard? So again, an open box is to be constructed from a piece of cardboard by removing a square of side 4 inches from each corner and turning up the edges. If the box is to hold 576 cubic inches, what should be the dimension of the cardboard? So you look at this. You have a cardboard, and then you remove 4 corners. Side, so square 4 corners, side 4 inches. Take note, you have a square cardboard. That's why this is a square also. So the length of this is X, the length of this is X. Okay? But notice, after removing these 4 corners, you will turn up the sides to obtain an open box. And this will be the dimensions. You turn this up, you turn this up, this one up, and then this guy here up. So the height of the box will be equal to 4. Correct? This is this part here. You turn this up, you will get that height. The length, so you have 4 here, you have also 4 here. This guy here will be x minus 4 minus 4. And therefore, you have x minus 8. So this here is x minus 8. This here is also x minus 8. But those are the sides of the base. So you have x minus 8 here and x minus 8 here. Okay? So you have the open box, and you want this open box to hold 576 cubic inches, meaning the volume of this open box must be 576 inches. Volume, it's length times width times height. length is x minus 8, width is x minus 8 also, height is equal to 4. So you multiply all of this. Okay? So let us do this. The dimension of the open box is x minus 8 by x minus 8 by 4. So we need to solve for x. If the box is to hold 576 cubic inches, the working equation will be something like this. 4 times x minus 8 times x minus 8 equals 576. But this one here, you have x minus 8, x minus 8. That's your x minus 8 squared. And then we divide everything by 4. So you put this on the other side, but that becomes division. 576 divided by 4, that's equal to 144. So again, what happened there? We divide everything by 4. You divide this by 4. So this 4 here will cancel the 4 here. And then this simplifies to 144. Okay? And then you have a perfect square here. All you need to do to solve this, get the square root, you solve for x. Okay? So in here, again, what did we have in the previous slide? We had x minus 8 squared. This is equal to 144. So this means your x minus 8, this is equal to plus or minus square root of 144. But this is plus or minus 12. Okay? And therefore, you have your x minus 8 equals 12 or x minus 8 equals minus 12. That's your plus or minus here. And
Excuse
then you
me.
solve for 8x. Sorry? Yeah,
I have a question.
sure.
I didn't understand where come minus 8.
It's from here. The box. You let us go back to the box here.
Sorry.
So you remove 4 inches here, you remove 4 inches here. The total length of the square is x. So this guy here, it's x. This is 4 inches. This is 4 inches. Those are the numbers that you will remove. So you will only get x minus 8.
Okay, thank you. That's it.
You're welcome. So finishing this, your x equals 20 or x equals negative 4. So you put your x to the right-hand sides. So here you have, you put your 8 to the right-hand side. So you will have x equals 12 plus 8. That's 20 here. Here you put the 8 on the right-hand side. You will have minus 12 plus 8. That's your minus 4. And then again, you need positive because we are talking about length. So we need positive. And therefore, we will only take x equals 20. Okay? So in this case, you will have the dimensions or the dimension of the card, the box. You will have 4 inches, 20 minus 8, 20 minus 8. So you will have a 4 by 12 by 12. Okay? And that's, if you multiply that, you will get 576 inches. So the dimension of the cardboard it's 20 inches. Okay? Question. No question?
No, no.
Yep. These are the examples where I will not record the solutions. Okay? So try to work on them. If you are going to review the video, okay, you will not see the solution anymore. So the solutions for the next examples, including this one, will be off the record when I upload this in the link in my channel. Okay. So first example that we're going to solve, you have x minus 5 squared equals 2x. So for the next example, we have here x plus 2 times 2x minus 1 equals x squared minus 1. We want to solve x squared minus 1 times x plus 2 equals x cubed minus 4. Next example, x cubed minus 6x squared plus 7x equals 0. So for the last problem, we have x plus 1 over 2x minus 1 equals 3x over x minus 1. Work on as many problems as you can on pages 58 to 61 of the 016 module. There's a lot of solving equations there. Okay. In fact, the last examples that I presented, they came from the 016 module. So I just picked them up from there. Okay. So if you don't have any question, I am dismissing you now. I still have time. I can stay to answer your questions just in case you